Who is talking to you today? It's me. I'm Thilo Volprich, CEO and founder of Team Technology. We have been Beacon Award finalist. I'm an IBM champion, and I'm proud to be HCL ambassador also in the last 2 years. I love Domino, and I'm doing that stuff since 2003. Maybe you're asking why I am talking about JavaScript today, because more and more applications are becoming available in the browser. And if you want to work in the browser and solve any problem there or have any functionality there, you have to act on JavaScript. And most of us are LotusScript developers or Java developers and maybe don't know all the features and problems you may have with JavaScript. So today I want to talk to you about one very specific problem. It's called the callback hell and how to resolve this. I will show you some examples today. So if you are interested to get these examples, just drop me an email. You see my email address here. So if you're interested to receive the example, just drop me an email and I will send you all the examples. Let's jump into how JavaScript works. The main question is JavaScript synchronous or asynchronous? JavaScript evolved so much, so it's really hard to say. As its base, in the beginning, JavaScript is synchronous. But that's not the entire story. JavaScript can behave in an asynchronous way. And what this means, I will show you in detail in the next 40 minutes. So let's jump into step by step. Synchronous code. What does this mean? JavaScript is in the base is synchronous. That means one operation can be in progress at any time. Not two, not more, just one. Each step of an operation waits for the previous step to execute. One line blocks the next line to run. So the same as you know about other languages, programming languages, there's one step after another and the next line is waiting until the previous line is executed. What this means, on the other hand, is one single function can completely block your site. And for this, I created an example, and I want to switch to show you my code and what I have done to show you this. So we are going to, this is Visual Studio Code, and I have created a demo website, just some header information, having some small CSS, and the information about the website itself. The important part is at the bottom here. So this is a code I am running. So we write something to the console, and then we add an event listener for clicking. So if I click on the page, then the on-click event is executed, just writing you clicked here. And I also call a code sync wait 5 seconds. So this is a code. You see the function here at line 26. We just write something into the console and then we have milliseconds. We take 5,000, so 5 seconds. And we just do a loop, a while loop, and loop over for 5 seconds. And let's see how this works in a browser. So if I go to the browser, and I start this code and I click while running. So I click here, I click, 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 and you see nothing happens. That's because the code we are calling before, the while loop is running. And afterwards, when all the while loop is done, then my clicks are recognized here and displayed on the screen. What you see here in the bottom of my screen is something console-like to make it easier to understand what happens here. So this is just a mirroring of the console to display what happens here. Okay? So this is the first example you have seen. And you see this is a very bad behavior because if I click something, nothing happens. So I get no response from the website. And this is not what we are looking for. So let's dive into what we can also do. So because JavaScript is able to behave in an asynchronous way. A nested code can wait for an operation to continue running. After the main code completes, it is sent to the queue. This happened at any time in the future, and then the event loop recognizes that the nested code is done, and then it runs afterwards. It's non-blocking, and it can run in parallel. So this is very helpful for you, as you can see on the right side. So we have 0.7. We have a callback functionality. This waits. The main code runs further, doing function D. And when the asynchronous code is done, then the queue recognizes this, giving it back, and runs the code after function D has been completed. So to make it easier, I just want to show you this way it works in another example. So I have a very easy example here. We have a functionality. So the top is always the same. Don't mind about it. So we have a function wait by timeout. We have a function on click, and we just add an event listener for the click event. So when I click anywhere in the page, the on click functionality is called, and then the set timeout functionality is called. And this is one of the easiest way to create asynchronous code. So the code after this line runs directly, and after 5 seconds, so after 5,000 milliseconds, the wait by timeout functionality is called. Let's see how this works. So if I go into the browser and open my demo 2, you see demo console started my script at the bottom in my mirror console. If I click here, you see button is clicked, and after 5 seconds, we get the callback functionality or the asynchronous code, which is called later. The good thing here is, while the code is waiting to call the second line, the website is not blocked. So I can click here, and you see there are all the things happening, showing me where I clicked. And then after a while, all the other code runs out and giving us the result of the code we have created before. So this is very helpful, and this is the easiest way to do it. So asynchronous code is better than synchronous? You're maybe asking. For programmers, it is. It's easier to work with synchronous code because you know the order of processing. As you have seen in my demo 2, we don't know when the second line of code will run and what runs in between. But whenever a function is blocking your site, the asynchronous code is better. And this is always true for longer running functionalities. For example, for requesting any data from another API, for doing a lot of change on the interface, if you connect to a database, or everything which is longer running. So the main reasons for using asynchronous code, just some examples here: grabbing data from an API endpoint, grabbing data from a database, and especially working with the file system. This is primarily on the server if you work with Node.js, for example. On the client side, it's not that easy to work directly with the file system. The target today: allow addition on your site while something happens in the meantime. So the code is not blocking, the site is not blocking. Every user on your page can work with the page while something happens in the background. The good thing is that most libraries out there, we are using libraries, we don't write everything on our own, have solutions for this case, so giving you the option to call code asynchronously. But how can I execute my code after the asynchronous code has finished? So we have some code which has to run after another. For example, we access some data, want to give out the username, read out the username, and then we want to display a dialog showing that. Therefore, we have to be sure that the asynchronous, the code, the dialog, runs after the asynchronous code has finished. For doing so, we have three different options. We can use callbacks, we can use promises, and we can use async await. These are three different ways within JavaScript how you can solve this problem. We will see all of them in a second. And we follow the order in which the language itself has evolved. So JavaScript started with callbacks. Then in 2000, I don't know, we got promises. And the newest change is we get async and await. So I just want to make sure that you understand how the code works and how you can escape the callback hell, because this is an old code and yeah, it's hard to understand. So we start. What is a callback? A special feature of JavaScript is that parameters of a function can be functions themselves. In other languages, for example, only values or variables can be transferred here. So if you think about a function, you create a function, do something funky, and after that code finished, you want to run something special. So you can put in the code which runs at the end into the signature of the function itself. So not only having a first name and a last name in the parameters of a function, you also can have a function itself. Functions which are passed as parameters in outer functions are so-called callback functions. Within the outer function, we work with the callback with the inner function. We can use parameters within these nested functions too. So everything you can do with every normal function. And often callbacks are the last code line of the outer function. I show it in a second. Callbacks make sure that the function is not going to run before a task is completed. This is what I'm talking about asynchronous code. We have to wait until the asynchronous code has finished, and then we want to go on calling our inner code. Let's see an example. Maybe this is easier. So let's switch to demo 3. So this is a little more code to read, but it's very easy to understand. What we are doing here is we want to get a quote. I found an API, an open API in the web, where we get the quote of the day, quote of today. And after that, so this is, we are calling the first functionality, and we put in as a callback this line. So we give the code we want to run after this has run into the next functionality. And if you look at the get quote, here is the get quote functionality. We do some stuff, read out the quote of the day by a get request, want to have a response type of JSON. And when the code is finished, so we get the result, we check if the status is okay, so 200, or if there is any problem. And if the status is okay, we call the callback. So we call the next function we want to run afterwards. Because afterwards, we want to write this code to the website. This is done by using this code, this functionality. We write code to the HTML, and we also have a callback here And this is the translate code. So we jump into the next functionality. I have created a key for accessing DeepL. DeepL is a translation service. If you see this key, this is my key, and I will deactivate it after the session. But right now I need it to access the data. And we do an authorization, get the response, and write back the data. So at the top, we see all the functions. And you see how these functions are combined together here. This is the main code. So reading, get the quote, afterwards using the result data we have, write the original quote to the website, then translate the quote into German, DE, then translate the code into Spanish, AS, then translate the code into Russian language. So if I go here and show it to you, you will see the result at the top and in the console also. We start here and you see there's all the things are happening one after another. So we get the quote, then we translate the quote to quote of the day to German, then we translate it to Spanish, and then we translate it to Russian. Okay? And you can see here, get quote is called, writing the quote, translate the function, translate the next function, translate the next function, and all the code is run one after another, even if we are doing asynchronous things like calling the API. But as you can see here, this is the problem with doing it that way with the callbacks, because it's really hard to understand what happens here and what happens one after another. And especially if you have to put in another function, you have to write between these two, for example. You always have to find the right place where to put in the function call, giving back the right function, and especially doing all the closing things on the right way. So it's really hard to do it. What is happening here? The outer function is called. If there are other functions outside the callbacks, they run immediately. We don't have them in our example. The inner function is delayed until something happens after the outer function, mostly asynchronous, is finished. The callback, the inner function, is called by the outer function. You see on the right side what's happening directly, especially in the browser, and how this is being done. And as you have seen, the callback inner function is put to the end of the stack, and then it runs out. And so we have a synchronous behavior, even if we are working with asynchronous code. So this is the explanation how it works. Which parameters can I use within the call? I can use outer parameters, noun before the inner function runs, and inner parameters determined during the execution of the inner function. Just think about, we have to get the result from the API to get the quote of the day, and then we work with this quote because we want to translate this quote. Let's break it down to a single call. We write the original code. This was our functionality. We have error data, so the things we put in, and then we call asynchronously the function translate code. This is always done in the way you see it here. So we put in a function error data as last parameter of the function call. We have translate quote. This is the function we want to call within original quote. And we combine data from different sources. So we use the error and the data we get while runtime of the code, and we add some additional data, the DE you see here, in the meantime. So we combine from the outer side, the DE, with the data we will receive within the first code. So, and you see in the bottom, call within. So within the function write original code, quote, we have a call for calling the callback with the error and the data. And this is how it works, and you have seen it in the example before. This is really ugly. You have to handle errors in every callback function. Right now you see just the callback calls, but if there is a problem within this chain of different calls, so it's really hard to get the error handling right. It's really hard to read the code also, as you've seen before. You don't like to read this if this is really heavy and really big. We just had 5 calls right now. And it's even harder to change existing code. So if you have code written by someone else and you want to understand it, it's really hard to get into it. Very own this opinion, always use a code checker. So like ESLint, to be sure to not have any syntactical problems in your code. If everything works, it's fine. If there's a problem, I'm happy if I not have to solve it, because it's really heavy to work into big callback change. This change functionality, chained means one after another. Calling is called callback hell, like we have seen in our example. And today my target is to show you ways how you can get around this. One of the easier ways is working with promises. Maybe you have heard, maybe not. What is a promise? It's a function that ensures that sometime in the future a positive or negative result will be returned. It uses a special structure within the function. Based on a positive or negative result, we can react differently. So very easy, we call a function, and in the future, we don't know when, but we know it will. We get an information if everything has worked, so resolved, or if there was a problem, rejected, and then we can go on and call the next code. The human readability, in my opinion, is very good, and it's much easier to understand the code. States of a promise. First of all, a promise is an object. So is JavaScript, everything is an object, nothing special. We have 3 states a promise can have. Pending, this is the state when we call it and we wait for a response. We have resolved, everything works and we got a positive result. Or rejected, it's a failed promise, throws an error. For example, when we request data from a server by using a promise, it will be pending until we receive the data. If we achieve to get the information, we get a positive, so resolved successfully. And if we don't get the information, then we get a negative, a rejected state. This is how a promisified function looks like. So it's very easy. We just return a new promise. So this is a function as you write it down twice, 10 times a day. But the difference is you return a new promise. And you return it in that way, you see it display here. And then you just decide, you run your code. If there is an error in your code, just give back and reject. And if everything works, just give back and resolve. And this is everything you have to do, and then it works. Let's see the example for that. So same code as before. The only difference is I always use promises, return new promise, function, resolve, reject, and then I resolve the data. Same here, get quote. I promisified the function by doing this surrounding new promise. And then if everything is okay, we resolve. If there's a problem, we reject. The same with the translation here. here we also create a promise. And if everything is good, we resolve. If something is bad, we reject. Okay? And then this is the good point. Here you see how the structure of the code changes. So by using promises, it's really easy to work with all the nested functionality, even if we don't know how long every single of these functionality needed in time. So if we have a slow internet connection, maybe it's taking longer, but it's no problem, because by using promises, you have always the chance to chain the functionalities by using the keyword then. So, and it reads very easy. So we have get quote, then we are calling, and then is always called if we have a positive result. So we have a resolve. And then after this functionality, we have the next then, we have the next then, we have the next then. And the good thing is we always get back something. So we get back the result from the first call, and we can use it in the next call. We just put in the data we get from the first. And by doing so, we have all the information from the starting point to the end point and give the information we resolve from one functionality to the next. And one special thing, we have a catch thing here. So as I said before, if you use then, this is always called if everything works fine and we get a positive result. And if we get a negative result, we get a reject, and this is catched by the catch functionality. And as you can see here, this is very good for us and very easy, because right now we are able to get one error handling and use it for all the different functionalities we used before. So it's very clear and very structured. Let's see how it works on the browser. It looks the same. It looks the same. The result is the same. The different functionalities are called one after another. So the same as before. The only difference is that we have a very clean structure how we can work with the data. And if I want to create, if I want to add another functionality, I can put in at any place just another then. And then this code is called before the next. So this is, in my opinion, a very easy way to structure and to read the code. So this is the structure, again, of a promisified function. Just surround your existing code by returning a new promise, and then have a positive and a negative result. The code is similar compared to the callback hell, but it's much easier to read for human beings. And the then is always the next function we want to call. This can be repeated as often as desired. You have seen we have done it 5 times. The next function is always delayed until the previous function finishes. And we get the information from the previous function and can use the result in the next function. And the error handling is done by one single function just to catch the error and work with. So this is the difference. You see the left side, you see the right side, and they are doing the same at the identically code. But I think the right side is much more easy, much easier to read for human beings. And especially if you have to change the code, then it's more easy to do it on the right side compared to doing it on the left side. And the difference in promisified functions is not that big. you see we just surround the existing code by the return new promise function and then giving back a resolve or a reject functionality. And that's it. So it's very easy to promisify an existing functionality and make it work the way we want to work. The good thing is there are even more. So combining multiple promises and wait to finish all. So what we have done before is with the then, we created one promise chain. And by doing then, we are calling the next function and the next function and the next function. And we always wait until the previous function has finished. The good thing is we can have something called promise all. By doing so, we have the option to put in an array of functions. So for our example, we want to have 3 different translations: the German one, the Spanish one, and the Russian one. And for us, it's not important which one comes first or comes last. We just want to have these 3 translations being made. So what we can do here is we can easily call them in parallel and have a then, as we had before on a single call, when all the 3 of the functionalities have finished. If one of them fails, we can catch it and then handle the error by doing whatever we want. And as you can see here, we are doing now all the translation in one single call. And let's see what this means in a real life example, in our real life example. So we have the get quote functionality, we have the write original quote functionality, and the translate quote functionality. All of them are promises. And what we have changed now is we have the get quote. So this is our main code here. And what we are doing right now is we get the get quote. Then we start some information, writing some information to the console. And next we call write it. So we want to write the quote to the page. And then we are creating a promise all, as I showed you before, translating to German, translating to Spanish, and translating to Russian language. And then we resolve the values. After that, we give some information back. After that, if there's a problem, we have a catch to writing back the error. And the good thing is that within the promise chain, this is the outer promise chain, we have another promise within. So you can not only chain the promises itself, but you also have the option within one single call to have another promise or promise chain within an inner promise. Let's see how this works on the browser. You see, it's much faster because all of the 3 different translations are done at the same time. So we are calling the AP 3 times, and when all of them have finished, then we get the result. And you see, we have Spanish, Russian, and German one. But we don't know which of the API is faster. Sometimes one, sometimes the other is faster. So if you see at the sorting of these 3 of them, you see they may change. Spanish, German, Russian, Russian, German, Spanish. It depends on which API responds faster. So this is the reason why some of them are, sometimes they are first, sometimes they are last. You just get back all the information and we save time because we do it in parallel. Okay? Cool. Let's jump into in here. So this is combining multiple promises and wait to finish all, even within an existing outer promise chain. what is, okay, if you understand async, if you understand promises, maybe you're asking, why do I need async await? Async await behaves completely the same as promises do. It's just syntactical sugar. It's easier to write, but it's not from the behavior, it's completely the same. So async prepares a function for a controlled sequence. So if you want to use it, not use promises, but using the async await code, then you have to set this before the function name to make it work. So if you want to use this functionality, just, for example, you see async function do fancy things. You just have to put in the async keyword in front of the function. Await controls the segments within this code, within this function. So if you have a function where you want to use it, just write async in front of the function name. Await causes asynchronous code to behave like synchronous code. What this means is, okay, even if we have to wait for the code, we do wait, and the next line of code is running after this code has finished, even if it's asynchronous. The call code line must support this for sure. So the functionality you want to await for should be asynchronous code or a promise. You can work with the return value after, the same as we have done before. And the combination of synchronous and asynchronous code is, yeah, it's possible, it's easy. So here's an example. I have a function. I call it async function do it. So you see the one thing I changed is before the function declaration, I put in the keyword async. And then I said, let quote is await get quote, the same quote as we had before, but we put in await before. So the next line, the console log, we have the result now, is waiting, await until the let quote gets the result. And by doing so, we can call the code one after another. So just to make it clear, it's the same behavior. It's just another syntax, how we call the code. So these are the same code as we used before. We have promises, and we just do it. I call the function do it here. I have done this syntactical change because I want to call this code asynchronously. So async function do it. Here we await to get the quote. We get the quote and then we write back the result. Let's see how it works and if it works in the browser. So same result as before, just using a different way of syntactically calling it. So for me, it's completely the same how it works for me and how I, as a developer, can work with both of them. And I think you have to know both of them because you're not only working on your own code. If I have the choice, I use promises because I like the way this is displayed and how the code can be read by me. My personal opinion is it's easier to understand if you have promisified code and working with promises. But I can understand that people are using the async await syntax. So both is possible, both works, and both of them are miles ahead compared to callbacks, which was the starting point of today. So I hope you get an insight of how it works and how the problem of callback hell can be resolved by using promises or async await. And if you're interested in, drop me an email, thilo@teamworker.com, and you will get all the examples all you have to do is to create your own DeepL translation key, because you can't use mine. And then you can check it out and test against all the code. And now I'm more than happy to answer your questions if you have one. So if you have a question, please use the Telegram channel to put in a question, or use the chat functionality, but you don't, please don't do it in full screen. Then you have to authenticate and then you can put in your question.
Dear Thilo, I think our users don't have any question. We just want to say you many thanks for the story how to avoid hell.
Okay. It's always good to avoid hell.
Yes.
Okay.
Thank you.
Yeah, thank you, Margareta, and thank you for all the listeners. Enjoy your weekend. Bye-bye.
Bye-bye.